what we are looking at, thank you, it's recording. All right, we are looking at measures of central tendency and we're looking at the mean today. So when we analyze data, we try to find typical, normal or average scores. There are three measures of central tendency: the mean, the mode and the median. So the mean has a symbol X bar, which is the number of scores, and we have that the sum of X, so sigma X, is the sum of scores. So we need to note that big capital E is the Greek letter sigma and is used in mathematics to stand for sum. The symbol X bar usually represents the mean of a sample for the mean of a population. The correct symbol is mu, okay, so that Greek letter. So how we calculate the mean, we know it is we all know how it's done. It's the sum of scores divided by the total number of scores, which we can represent as X bar equals sigma X over N. So there are occasions when it's very easy to find the mean by adding the scores and then dividing the total number of scores. However, we will be needing to know how to calculate the mean from a list of scores and from a frequency distribution table using our calculator, and this will later lead on to finding standard deviation. So we can do example 1 using our brains. So we have there are 5 children in a family aged 13, 19, 11, 17 and 10. We want to find the mean of their ages. So to find the mean, it is X bar equals sigma X over N. So what that is saying is that we're going to add our scores together: 13 plus 19 plus 11 plus 17 plus 10, and put that all over the children in the family, which is 5. Okay, so when we do that, we get 70 over 5, which is equal to 14. Okay, so therefore the mean of their ages is 14. Okay, we can also use our mean by using the calculator. Now you all use the Casio FX 8200 AU. So on your calculator, you press home, statistics, 1 for variable, and then you want your memory cleared, and then you enter your scores. So you go 13 XEX or equals, 19 equals, 11 equals, 17 equals, 10 equals. You then press equals, you press 1 for variance results, and then XEX. Oh, you probably don't need to clear your memory. There'll be nothing there. Does it come up with clear memory?
There's I just like that. 14.75.
Okay, so when you go home, 1 variable, home statistics, 1 variable, we all done that?
Yes.
Did you get your mean is 14? It shouldn't be 14. 13, 19. Has everyone else been able to work it out? Do people need me to show you them on their calculator? How do you clear it? You just go settings, reset, data, yes.
It's like a spam.
Or you can go edit and delete all. So you can go tools, edit, delete all. Alright, does everyone know how to do that now? Yeah? So for the mean of larger data sets, it's easy to sort the data into frequency distribution table to add up the scores. The mean of data in a frequency table is X bar equals the sum of your FX column divided by your sum of your F column, where sigma FX is the sum of each score times by the frequency, and sigma F is the sum of all frequencies. All right, let's look at this example. So we want to find the mean number of hours that members of a class practice piano each week. The numbers of hours for each student is. So we want to put this into our table. So how many 1s are there? 5. How many 2s are there? 6. How many 3s are there? 3. How many 4s? I only see 1 4. How many 5s? No, there's only 2 5s. And how many 8s? 6s. There's 8. All right, so the sum of that is 5 plus 6 plus 3 plus 1 plus 2 plus 8. Means that we have 25 scores there. Okay, to find our FX column, what we do is we do our 2 other columns multiplied together. So we do 5 times 1, which is just 5. Okay, 2 times 6 is 12, 3 times 3 is 9, 4 times 1 is 4, 5 times 2 is 10, and 6 times 8 is 48. We then add that column up to get 88. So our mean, which is our X bar, is equal to our sum of our Fx over our sum of our F, right? Our sum of our Fx is 88. And our sum of our F is 25. So this is just 88 over 25, which equals 3.52. Okay, and so therefore the mean is 3.52. Now we also could have put that into our X and our frequency by using our calculator. All right, so we can do it with turning our frequency on. So on our calculator, we can check that we are right by going home, statistics, 1 variable. We then hit tools and we turn our frequency on. Okay, and then we enter in our X column our number of hours, and then we move across to our frequency column once we've entered all of our hours to do our frequency. Once we have all of our data, we press our EXE button, and then we go 1 variable results EXE, and we should be able to find our mean is 3.52. Tools, and then frequency. Alright, is everyone able to do that on their calculator? Yes? No? Okay, so although group data is not completely accurate because we don't know exactly what scores are in each group, we can still calculate an estimated mean. So from the table, we want to find the mean commuting time that a sample of people take to travel to work. So what we have to do is use our class center. Just to recap on finding class center is equal to our ends of our classes, so 0 plus 8, and then we divide that by 2 to find the middle, which is in this case 4. Okay, we can't really see a nice pattern straight up, so our class center for our next one would be 9 plus 17 divided by 2, which equals 13. Okay, we can then work out the next one to be 22, 31, and 40 by doing that. To find our frequency, our sum of our frequency, we add 3, 5, 7, 8, and 2 together to get 25. And then our F times our CC is our class center column times our frequency column. So 3 times 4 is 12, 13 times 5 is 65, 22 times 7 is 154. We have 31 times 8 is 248, 40 times 2 is 80. Okay, we can put that into our calculator to work out the sum of that. We can get that X bar is equal to the sum of our FX or our FCC column divided by our sum of our F column. So that's 559 divided by 25, which means that X bar equals 22.36. Okay, to work that out, we could have also just put in our class center column and our frequency column into our calculator, and that would have done it for us. Flip the page when you're ready. I believe we have some more. Okay, so what we have next is we have the mode, okay? So we've just talked about the mean, we now have the mode. The mode is the most frequent score. There is no mode if all the scores are different, or there could be several scores with the same frequency. With group data, instead of finding the mode, we find the modal class. The mode is useful when looking at trends such as the most popular types of clothing. It can also be used for categorical data. So what is the mode of these sets of scores? 7, 4, 3, 5, 7, 1, 2. It's 7. Mode equals 7. Okay, to find the mode of these shoes sold at a shoe store, so the highest frequency is what we're looking for. So, yeah, the mode is going to be 7.5 because it occurs the most frequent. Okay, now we want to find the modal class for this data set showing the ages of people at a caravan park. So which one has the highest frequency? Yeah, so the modal class is equal to 50 to 59. So mode is just the most popular score. Okay, then on our next page, we have the median. So the median is the middle score when all scores are in order. Okay, if there are two middle scores, then what we have to do is find the average of these two scores. The median is the middle score when all scores are arranged in order. It is important to know that the median is also known as quartile 2 or Q2. Okay, so they're the same thing. When calculating the median from a table, adding the cumulative frequency column can make things easier. So we want to find the median age of people in a band. They are of ages 18, 15, 20, 18, 17, 16, 11, and 13. The first thing we need to do is put our scores in ascending order. So we will have 11, 13, 15, 16, 17, 18, 18 again, and 20. Okay, so what we do is our median is in the middle, so we can underline each score until we find where the middle is. So our median is going to be in between 16 and 17. We're all smart enough to know that the median is going to be 16.5, but what we have to do if we're not sure is go 16 plus 17 divided by 2 to get our 16.5. Okay, you could have two really different numbers there, and we can use that to do so. Okay, we can also find the median from a data set, from a table. Okay, I believe you can put this into your calculator and it will tell you the median as well. Okay, it will tell you the Q2 if we were to put this straight in, but we can also create our cumulative frequency column. So our cumulative frequency column is 3, 5, 9, 16, 22, and 25. So what we have here is how we work this out is our median is equal to n plus 1 divided by 2 in order to work out which score it is. So the median is equal to 25 plus 1 divided by 2. Okay, so that means it's the 13th score. So where would our 13th score be?
8.
Yeah, so our median is equal to 8 because our 13th score is there.
You do it the long way as well.
Yes, you could write everything out and do it the long way as well, but that would waste time. Okay, so we can also, we can calculate the median using the statistics mode as well. Okay, another way of finding the median is from a cumulative frequency polygon, or called an ogive, and we simply use the halfway point on the cumulative frequency axis of the origin. So halfway between our largest score there is 27. So we have to work out what half of 27 is, and half of 27 is 13.5. So what we do is we draw a nice straight line going across at 13.5. Okay, Okay, until we hit our ogive or our polygon, 13.5, that's down here. Okay, and we get that our median is at 1. Okay, so therefore, median equals 1. All right, we just have outliers, and then you guys are good to go on the exercise. So this is like just a recap of stage 4 and 5 calculus and measures of centre. Okay, the last thing is outliers. So sometimes a set of data contains a score that is unusual compared to the other scores, such as some of your test results might be unusual to other people's test results. So this unusual or extreme value is called an outlier. So an outlier is a very low or very high score that is separated from the rest of the data. And keep your hands to yourself. An outlier can affect the mean quite significantly, as the mean value is calculated using every score. So what we have here is the prices of houses sold in the town of Greenfield in a particular week are as follows. Is there an outlier? Why do you think an outlier may be in this data? Where's the outlier? This one. Okay, and the reason is because house prices vary. It might be a really expensive, like the best house on the street. Okay, we want to find the mean house price with and without the outlier. So in your calculators, can you find the mean with the outlier and the mean without the outlier for me, please? So find it with the outlier and then take it out, or do it the other way. Actually, find the mean with the outlier and the median. So the median is your Q2 on your calculator. Whatever you want to do, you can do either or. You can put it in first and then take it out, or you can do it the other way around. Okay, your median should be your Q2 value when it comes up on the screen. Are you sure? Okay, write it down then. I got 452. Yeah.
Oh my god. What have I done?
With it, the median is the Q2. You might have to scroll down to find the Q2.
I found my mistake.
Yeah, with?
Yeah. Oh my god, I clicked the answer button and it says statistics variable 9.
Press home and go back. There's no symbol for mode. Just write the word mode.
368,888.888.
So that's without it.
Yeah.
Has anyone found the median yet?
Is that the one that has X2?
No, it should say Q2. Have you got the data? So scroll down. Oh, there you go. Median. Oh, it says median. It says med. That's good. Doesn't it say Q2? But it's the same thing. So 385,000 when it's with is the median, and 380,000 is without. What's the mode with and without the outlier? It doesn't change?
320.
Yeah. Great job.